Hello everyone, welcome back for part 2 of the 4.3 notes where we are talking about logarithmic equations. Since we're just getting the hang of things with these logarithms, we're not really going to be using the principles, as it were, or the properties of logarithms to evaluate these necessarily. What we're using right now is the exponential form, and then we're using basically what you would call inspection. Inspection means you look at it and you tell the answer by looking at it. There's not much to do. You know, what it means, for example, for number 8, we're evaluating this expression, log base 12 of 144. Now, thinking about our context of what it means logarithm, it's asking this question, 12 raised to which power is 144? Because, of course, this is going to be, we're evaluating it, we're trying to find x, in other words. We're saying this thing is equal to x. If we can find out what x is, then we've evaluated it. We've found the answer for this question. For this one, and for these problems that we're able to solve by inspection, it has to be obvious what the answer is. And the way to make it more obvious is to convert this thing into exponential form. Of course, we can do that using our little loop-de-loop method. It's going 12 raised to the x power is equal to 144. And that's just because, like I said before anyways, before doing this conversion into exponential form, this function, it tells you which power you need to put as the exponent for 12 in order to get 144 as an answer. It's doing something in terms of an inverse of exponential form. Logs are inverses of exponents. And so what we have here is that 12 raised to some power is 144. Of course, we know that 12 squared is 144. At least you should know it. It's that famous last entry on the normal multiplication tables. And so 12 squared, it should be squared, is 144. So actually, this expression, it just evaluates as 2. That's the answer, is 2. We have something else for this one, the next problem. 64 raised to some power is 8. That's the question. 64 raised to which power is equal to 8? Can you think of it? Of course, we know that the square root of 64 is 8, but square root is which power? It should go 1/2 power there. 1/2 power, so that's actually the answer. Log base 64 of 8 is 1/2, because 64 raised to 1/2 power is 8. And then we have something similar for this one as well. 3 raised to some power is equal to 1/27. Now this one is a little bit tricky. Which one should give us 1/27? Of course, if you go 3 to -1 power, it would be 1/3. And we know that 3 cubed is 27. And so actually, if this one could become 3 cubed down here, by making it 3 to -3 power, it would go 1/3 cubed, which is 1/27. So actually, that's the power that we want. The power is -3. -3 is the correct exponent to make 3 raised to that power to be 1/27. Now, just a couple of little notes for us here. There are some common logs that we don't actually use, and I mean to use the word common with 2 different definitions here. There is something that's called common logarithm, and that one, there's a button on your calculator that just says log on there. When you just have a raw log that has no base, it's implied that there's actually base 10. Because, of course, in our number system, we use base 10. Even though it's not so frequent, to have exponential equation necessarily that has the base of 10. Nevertheless, log base 10 of x, we will simply write as log of x. We just drop the base for that when it's understood what the base is when there's no base, that it's a 10. Similarly, whenever we use log base e, of course, e is a very famous, very powerful number whenever you're using it as the base of an exponent. And so what we actually end up doing is we give a special name to the one that goes log base e of x, which this is the inverse, of course, I will write it here. Inverse of this function that goes f of x equals e to the x. We would have an inverse like f inverse of x would go log base e of x. And then since these are inverses for each other, and this gets to be the special inverse for this nice thing that goes e to the x, then we will write it as ln of course it goes Ln like this, Ln of x, whenever it gets this lowercase l, it can sometimes be interpreted maybe as a capital I or something else, maybe a 1, I don't know. But people misinterpret this one all the time. It goes ln of x because it stands for these l and n words, which go natural log. And I don't know why it should be ln instead of nl, because it means natural log, but we go ln, so I guess it's kind of like log natural of x. And that's the one that we're looking at. Now we're going to try evaluating some of these that have these special logs. And so log of 100, we could rewrite it if we want to, just for the illustrative purposes. This means log base 10 of 100. And that, of course, the result from calculating this, it should tell you which exponent we need to put on 10 in order to get 100 as an answer. So 10 raised to some power is equal to 100. And so 10 squared is 100. So it's actually the 2. That thing will be equal to 2. And then we have also, this is a very nice one, log of 0.0001. And so it's kind of like 10 raised to which power is going to give us 0.0001. Now which number is this? Can you figure out which number this is? It has these decimal places. You know, this is the tenths spot. Tenths. Also hundredths, thousandths, 10,000ths. So this is actually the number 1/10,000th. So it should have 10,000 on bottom, which to get 10,000, that has 4 zeros, and so that's like 10 to negative 4 power is the same number. It will go a 1 on top. It goes 1 over 10 to the 4th power, which is 1 over a 1 followed by 4 zeros. That's what it means, 10 to the 4th power, a 1 with 4 zeros. And so those are the same number, so actually the answer should be negative 4. 10 raised to negative 4 power gives you 1/10,000th. Similarly, we have for these, ln of e to something power. We will see it as one of the properties for logarithms, that if you have the same base as you have here, the argument has the same base and it's raised to some exponent, the answer will simply be whatever the exponent is there. Because of course this one, it's going log base e of e to negative 3 power. And so it's kind of a funny question if we put it in exponential form, because it's saying e raised to which power is e to negative 3. And you can see it as plain that the power is negative 3 power. That's how you get e to the negative 3. It's by raising e to the negative 3 power. And so that is the answer for that one. And then we have it again. E raised to which power is going to be e to the 10th power. And of course it's the 10th power. These are kind of funny questions, but we'll see it all the time. ln of e, it's reoccurring. And so we want to get comfortable with using that one as well. But anyways, we're going to carry on with logarithms. We'll see how to graph them, for example, and then we will start doing some really nice logarithmic functions where we will have maybe some equations as well that we can solve. Here we've just been doing expressions, you know, just evaluating some expressions. We want to start actually solving equations that have log in there, and we will solve equations that have exponents as well. Of course, we cannot solve exponential equations until we have the inverse, which is now made manifest that it is the logarithmic function. And so I hope this video was helpful to you guys. Thanks for watching, and I'll catch you in the next one.